Hello students, today we are going to talk about how to find the sum and difference of cubes or how to factor a polynomial where you notice that there is a sum or difference of cubes. Remember we've talked before about the difference of two squares. For example, if I have x squared minus 25, you've learned that to factor that you would take the square root of x squared, which is x, and you would take the square root of 25, which is 5, and that the signs would be opposites of each other or different, so one positive, one negative, and x squared minus 25 would factor to be x plus 5, x minus 5. This is kind of like a pattern that we notice after we do lots of these, and we can use that algorithm or that pattern to factor anytime we have the difference of two perfect squares. Well, this is kind of the same idea, but instead of the difference of two perfect squares, we're going to be looking at sums and difference of two perfect cubes. The pattern is pretty simple. This is what it looks like in algebraic terms. So if you have x to the third power plus y to the third power, that would factor into x plus y times x squared minus xy plus y squared. And the difference of two cubes, you should notice, is very similar, except some of the signs are in different places. Let's talk about some strategies to help you to remember how to factor this when you actually look at some problems. The memory trick that we use is called SOAP. Now, what SOAP does is it tells us that if our sign is positive, the first sign that we come to is going to be the same as that positive. The second is going to be the opposite of positive. And the third one is always positive. So you can see the same, opposite, always positive in the SOAP for SOAP. So if you can remember SOAP, you can remember same, opposite, always positive. This is the same for the subtraction problems where we have the same sign, change it to positive for the opposite sign. And the last one is always positive. You'll also notice that once we take the cubed root of the first term and the second term, there's a pattern in how we plug those in as well. The first parentheses is going to get the cubed root of x and y. In the second one, we're going to start with the first term squared, plus or minus, depending, of the first term, cubed root of the first term times the cubed root of the second term, plus the second term squared. So as we look at some practice problems today, you'll see this pattern over and over again, and hopefully after practicing yourself, you'll get really good at it. So what I've already done is I've already kind of not factored, but I've already taken the cubed root of the first term and the second term. And I'll quickly show you on your calculator how to take a cubed root if it's something that you haven't done before. So I know that x to the third power, the cubed root of that is going to be x, because x to the third power is the same thing as x to the third power. What I want to find is the cubed root of 216. Now, some of you may know your perfect cubes. I recommend that you know a few of them, but your calculator, although it doesn't have a cubed root button on it anywhere, if you click Math first, you'll notice that the fourth option is a cubed root. So if you click the number 4, or if you select the fourth option, you'll see the cubed root pop up on your calculator. And we want to find the cubed root of 216 for this first problem. And you'll notice that we get 6. So if you don't know that something's a perfect cube, just put it in your calculator and see. Now your calculator does higher roots as well. It's called an X root. It's in the same place. You hit Math, and this is the X root button right here, the fifth option. In order to do the X root, you have to put in your number first. So if you want a fifth root, for example, you'd have to put the 5 in first, then hit Math, then choose the X root. And you could find the fifth root of a number. Now, we're not going to be using fifth roots today. We're not going to be using fifth roots, only third roots. So that fourth option is going to work for you every time today if you are unsure. So what I was saying is I've already done all of these cubed roots so that you don't have to worry about them as you're going through the notes. But just know how I got them was I took the cubed root of, and for example, in the second one here, I took the cubed root of 8 x to the third. 2 to the third power is 8, so 2, and then x to the third power gives us the x to the third, so 2x is the cubed root. And for 125, I took the cubed root of that to get 5, because 5 to the third power is 125. Now, once I do this, I'm going to first use my SOAP technique. to get my sign. So my first parentheses is going to be a little smaller than my second one, and I'll look at the sign here and remember SOAP is same, opposite, always positive. I'll go ahead and do number 2 here. Same is negative in number 2, opposite, always positive. And now I'm going to fill in the rest of the formula. Okay, so as we're working these problems out, the first parentheses is always going to get the cubed root. So it's going to be x and 6 in number 1 here. It's going to be 2x and 5 in the second one. It gets exactly what the cubed root is. Whatever that is goes there. For the next one, you're going to start by squaring the first term. So x squared is just written as x squared. And you're going to end it by squaring the second term, or the second root, which is 6. Cubed root is 6. So 6 squared is 36. And then you're going to get the inside by multiplying the 6 times x, or x times 6. So that's 6x. So remember, the first one stays the same. We're only using these numbers that once we figure out what they are. The first one stays the same. The second one, you square the first, then you multiply them together to get the middle, and then you square the last. And that is it. We're going to look at about 10 of these today, and we're going to go fairly quickly. And as you get comfortable, as you kind of realize the pattern, pause the video on the beginning of a slide and see if you can work it, and then hit play and see if you get it right. And if you get a few of these right, then you know what you're doing, and you can probably stop watching the video or fast forward to the end. So here we go. 2x to the third power. Well, 2 squared is 4, and x to the third power, x to the second power is x squared. So we're going to square the 2 and the x. Okay, so 4x squared. We're going to multiply these two together to get the middle. 2 times 5 is 10, so that's 10x. And then at the end, it's the second term squared, 5 squared, which is 25. So this is how it factors. You use SOAP to get your signs, and then you use the pattern of the first parentheses getting the perfect cubed roots. The second one is the first one squared, multiply the two together, the second one squared. All right, so 3 and 4 have a slightly different thing going on here. Again, I've already kind of shown you what the cubed roots are, done that already. So we're going to start with 3x. Actually, let's not start with 3x. Let's start with SOAP. Let's go ahead and get those signs in there so we make sure we get those right. Same, opposite, always positive. Same, opposite, always positive. And now I'll fill in everything else. All right, so 3x and 2 go first. Remember, it's just these parts inside. Okay, so 3x and 2. And then we're going to square 3x. 3x squared is 9x squared. We're going to multiply 3x times 2 to get 6x. And then we're going to square 2 to get 4. You get used to that, you got it made. Number 4 has something kind of unique that you see sometimes. Let's say that I didn't realize that there was a GCF here first. So what I would do is I would get my calculator out, and I might try to take the cubed root of, let's see, that's number 4, fourth option. I might try to take the cubed root of 54, and what's going to happen is I'm going to get a decimal, and I'm going to say, well, that didn't work. Well, that's a clue to you that this is not going to factor easily, and there's some reason for it. Well, the reason is that 2 and 54 are both divisible by 2. So we want to divide out that greatest common factor first. We want to divide the first term by 2 and the second term by 2. And what you'll notice often with these problems is once you do that, you do end up with 2 perfect cubes. In this case, it's x to the cubed and 27, which is 3 to the third power. Now, when you're factoring, when you pull out a greatest common factor, it is a factor. It should be at the front. It should kind of follow through the problem and still be there. But once we pull out the 2, we're going to apply our pattern with what's left behind, the x cubed plus 27, which is x to the third power plus 3 to the third power. So I'm going to start my first parentheses with x plus 3. Then I'm going to square x, multiply x times 3, and square 3. Very quick, very easy to do. All right, again, let's start with our signs using SOAP. Same, opposite, always positive. Same, opposite, always positive. So the same comes from whatever sign you start with, and then you change it to the opposite, and the last one's always positive. Now, when I'm squaring 4x, I've got to square both the 4 and the x, right? So that's a little different here, maybe. But we first start off in our first parentheses with exactly 4x and 3. That doesn't change. It's whatever we ended up with when we took the cubed roots. For the second parentheses, 4 squared and x squared is 16x squared. 4x times 3 is 12x. And then 3 squared is 9. Our first parentheses for number 6, we're going to put 3x and 4. Our second parentheses, we're going to start with 3x squared, which squares the 3 and the x. We multiply 3x times 4 to get 12x. And then 4 squared is 16. I hope you're feeling good about this so far. A few things that sometimes throw students for a loop is they don't know what to do when they get a 1 because they don't see that as a perfect cube. But in fact, 1 is a perfect cube because it's 1 to the third power. 1 is really special in that it's the same. 1 squared is 1. 1 to the third power is 1. 1 to the fourth power is 1. So we can still apply the pattern here. We'll start with our SOAP. Same, opposite, always positive. Same, opposite, always positive, right? In the second example here, number 8, we've got same, opposite, always positive. Now I'm going to apply the pattern to get 2x minus 1. I square 2x to get 4x squared. Multiply 2x times 1 to get the middle part. And then square 1 to get 1. Number 8, here's another example of two numbers that are not perfect cubes, but once we factor out the greatest common factor of 3, which remains a factor to the very end of the problem, it should be part of your final answer. It just doesn't go away, it's still there. Okay. We do end up, once we divide out the 3 with 2 perfect cubes, x cubed and 4 cubed. So we start plugging those in as x minus 4, then x squared, plus 4 times x plus 4 squared, which is 16. Piece of cake, right? These are our last 2 examples today. Let's see if we can do them really quickly. I'm going to do SOAP, same, opposite, always positive, right? Which is same, opposite, always positive. And then same, opposite, always positive. When I say opposite, I mean opposite of the first, okay? So same is what we start with, then change it to its opposite, and then the last one's always positive. And then we start plugging in things. So I'm going to, even though the x is second here, that's okay. It doesn't really matter. I can still apply the pattern where I do 6 minus 3x. Remember, I'm just using the part once I figure out what it is. I'm going to square 6 to get 36. I'm going to multiply 6 times 3x, which is 18x. Then I'm going to square 3x squared, which is 9x squared. For number 10, I've got x plus 2, x and 2, x squared minus 2 times x plus 2 squared, which is 4. Okay, you've got some practice problems with these. I feel like students generally do really well with this once they practice it a bit and they get that pattern down. It's something that they can do at any time. So I hope that you have a lot of success, and I'll see you in class.